Hello everyone, and welcome to section 9.5, which is about hyperbolas. Now, despite the fact that these sort of look like two parabolas facing in opposite directions, these are actually pretty closely related to the ellipses. So some of the things are very similar. Notice the standard form of the equations look pretty similar. Huge difference, we have a minus instead of a plus. And whether we are vertical or horizontal is no longer based off of which number is bigger, but rather which one's first. So if my x is positive, and x is my leading term, then I have a horizontal major axis. If my y is leading, I've got a vertical. So we have each of these are still equal to 1, and like I said, these are pretty closely related actually to the ellipses. Think of them sort of as the ellipses turned inside out. And I'll show you what I mean with the graphing for these. So we do have asymptotes, kind of as seen in the picture above. We are only going to have these at the origin. So again, if I have a leading x term, I'm horizontal. My asymptotes, the easy way to figure out the equation is going to be, it's pretty much your y number over your x number, where of course you take the square root to get the actual distance. And then your vertices come from, again, that leading term. The big difference in the relationship between a, b, and c is that c squared equals a squared plus b squared. So with ellipses, we had a plus in our equation, a minus in our relationship. With hyperbolas, we have a minus in our equation, plus in our relationship. So they kind of flip-flop. For your asymptotes, when you're graphing them, really you're going to be graphing them through the sort of box that's going to be guiding our graph more so than the actual being very specific on your asymptotes. So let's see what I mean with graphing these guys. First thing, just like with ellipses, you want to make sure that you're in standard form. So here I see I'm currently equal to 324 instead of 1. So if I divide everything by 324, and 9 times out of 10, pretty much that number is going to go in the denominator of the first one. The first number is going to go into the second number, and that's what we're going to get. So I have y squared over 9 minus x squared over 36 equals 1. Now I'm going to graph my vertices and then my co-vertices, which actually aren't going to have any points going through them for the actual graph. So I see I have a y squared, so I'm going to be vertical. Now I'm going to graph my sort of co-vertices, and really they're not going to be points actually on my graph, but they're just going to help guide this box that helps me draw my hyperbola. So square root of the number underneath the x is 6. Now I draw a box to connect these points, and I do want to stay so that my width and height correspond to wherever I drew my dots. So my a squared is 9, making my vertices 0, positive, negative 3, just like I graphed. My b squared is 36, making my sort of co-vertices positive, negative, 6, 0. For my foci, remember I don't have to graph these, but I have that relationship c squared equals a squared plus b squared, minus in the equation, plus in my relationship. So I have 36 plus 9, which is giving me a c squared of 45. So my foci go with my vertex, so it's going to be a y value. Square root of 45, square root of 9, and the square root of 5, so I have 0, and positive, negative 3, root 5 for my foci. So I'm going to connect the corners, so to speak, And realistically, I'm just drawing a diagonal through each corner of my box, aiming to hit right around the origin, because all of these are going to be centered at the origin. This particular one was vertical, so I know that these two are the actual vertices that I'm going to be graphing off of. So, off of my actual vertices, I graph my hyperbola branches. The equation for those asymptotes is positive, negative, the y number, so in this case 3, over, in this case, 6x, and then 3 over 6 simplifies to 1/2. That's approximately what the slope is here, but the exact slope doesn't have to be exact according to your equations. Use your box more so as your guiding point for where your asymptotes are. Let's take a look at another one. So here I have a leading x term, which means I'm going to be horizontal. I'm already in standard form, so I don't have to worry about dividing by anything. My vertices, well, they're going to be x values, so positive, negative, 7, 0. My co-vertices, which again aren't actually a part of my physical graph, square root of 9 is 3. Let's get our foci out of the way. So I take my a squared plus my b squared. (49 plus 9 gives me 58. So if I take the square root of 58 to actually just get c, which in this case is going to be an x value following along with our vertices, we have positive, negative root 58, which again, don't have to really graph them, it's not very pretty anyway. Draw your little box to help guide your graph. So we have a horizontal one. I know that I'm going to be mainly focusing off of those x values after I graph my diagonals. The exact value of those asymptotes, I want my y value over my x value. Just remember, like slope is rise over run, so positive and negative 3 over 7x is the technical equation. Using our box as a guide, much nicer. So I'm horizontal, so I go off of my horizontal vertices and go toward the asymptotes. These look far less exact than pretty much any of the other conic equations. However, we do have sort of the guide for how we're going to graph them. And if I was going to be writing an equation, so here I have foci at negative 5 and 5, vertices at negative 4 and 4. So I know that this one is horizontal based on the fact that my vertices are x values. So I know I've got x squared first. I know I have to equal to 1. If I square the distance to my vertex, I get 16. In order to figure out my y squared, I've got to take that relationship of c squared equals a squared plus b squared. So c squared in this case is going to be 25. If I subtract 16 on both sides, b squared is 9. And I have my equation. Even if this turned out to be a non-perfect square, if I'm just writing the equation, it doesn't even matter. I don't have to worry about taking the square root and simplifying because I want b squared anyway. So that's hyperbolas, kind of similar to ellipses, but the graph kind of looks like a parabola. We'll look at these a little bit more in class. See you then.